Welcome to the deep dive. Ever wonder how these massive complex systems actually, work? Like Amazon getting packages to you, or how an ER manages patients.
Hmm.
Today we're diving into something called operations research, or OR. It's basically the science of making smarter decisions in really complicated situations.
Exactly. Think of it as a way to get an edge, understand the hidden gears turning behind the scenes.
And our mission today is pretty straightforward. Pull out the key ideas about OR from our sources, make it clear why it matters to, well, basically everyone.
Right, and it's super interdisciplinary. It pulls from math, stats, computer science, engineering, economics, even management. It's a whole toolkit.
Again, comprehensive approach then.
Yeah, fundamentally, it's all about taking data, tons of it sometimes, and turning it into actionable insights, better decisions, basically.
Okay, makes sense. So where did this field OR actually come from? What are its roots?
Well, its origins are really fascinating, actually tied to World War II. Yeah, facing huge logistical and tactical problems, scientists in the UK and US started applying analytical methods. A classic example is optimizing radar during the Battle of Britain.
How did that work?
They analyzed data to figure out the best ways to deploy and maintain the radar systems. It sounds simple now, maybe, but it gave the Allies a significant edge in air defense. A really big deal.
Wow, applying that kind of thinking under such intense pressure. I think I read something about U-boats too. Anti-submarine warfare.
Yes, exactly. Or teams analyzed attack patterns, patrol effectiveness, convoy strategies, all that data. And they came up with much better anti-submarine tactics. It genuinely helped turn the tide in the Atlantic.
Incredible. So its power was obvious even back then.
Absolutely. After the war, people immediately saw the potential for business, for industry, and it just took off from there.
So let's unpack the core ideas. What's really under the hood of OR?
Well, at its heart is mathematical modeling. You take a messy real-world problem and you abstract it, turn it into a mathematical form, equations, variables, constraints.
Okay, like building a mathematical picture of the problem.
Precisely. And once you have that model, the next big step is optimization.
Optimization. Finding the best solution, right?
Yeah.
Not just any solution.
Exactly. The best, given whatever limits or constraints you have. That could mean maximizing profit or maybe minimizing cost or making something run way more efficiently.
Got it. So how do you actually do that optimization? What are some key techniques they use?
Well, a cornerstone is linear programming, usually called LP.
LP. Okay.
Think about, say, a factory making different products with limited resources, materials, machine time. LP helps figure out the optimal production mix to maximize profit. It's used all over the place for resource allocation.
What else?
Simulation is another huge one. You build a computer model that mimics a real-world system over time, like a hospital ER or supply chain.
So you can test changes. Like,
Yeah.
what if we did this without actually disrupting things?
Exactly. It's like a digital sandbox for complex systems. And then there's queuing theory.
Queuing, like waiting lines.
Yep. Analyzing waiting lines. Think call centers, traffic lights, checkout counters. It helps optimize service, reduce waiting times, use resources better.
It sounds like it touches almost anything involving systems and choices. Can you give us a few more, concrete examples across different sectors?
Oh, definitely. Logistics and supply chain management is a massive area. Optimizing delivery routes, think UPS or FedEx.
Right, how they plan those routes.
Yeah, minimizing driving time, fuel. Also, managing inventory levels, finding that sweet spot between having enough stock and not holding too much capital in warehouses, warehouse operations themselves.
Makes sense. What about something different, like healthcare?
Huge applications there. Patient scheduling, allocating beds or staff in hospitals, making operating rooms run more efficiently. These can save millions and improve patient care. It's really impactful.
And finance, I imagine they use it too.
Absolutely. Portfolio optimization, choosing the right mix of investments to balance risk and return. Risk management models often rely heavily on OR techniques.
It seems pretty versatile.
Yeah.
Any other surprising areas?
Well, you see it in planning school bus routes, managing water resources, optimizing public safety patrols, even in agriculture for crop planning or wireless communication network design. UPS is famous for using OR extensively. It's kind of everywhere once you start looking.
Okay, so it's clearly powerful now. What about the future? Where is OR heading with all the new tech coming online?
That's a great question. It's definitely evolving. AI and machine learning are becoming tightly integrated.
How so?
They help OR models handle even larger, more complex data sets, make better predictions, and learn or adapt over time. Think enhanced data analysis feeding into those optimization models.
And big data must be a factor too, right? Just the sheer volume of information we have now.
Totally. Big data creates both challenges and opportunities for OR. We need new approaches to handle the scale and variety of data. Also, quantum computing is on the horizon.
Quantum, how does that fit in?
Well, for certain types of really hard optimization problems, quantum computers could potentially offer exponential speedups. It's still early days, but the potential is immense.
Interesting. Anything else trend-wise?
Yeah, there's a growing focus on green OR, applying these principles to environmental and sustainability challenges, optimizing energy use, reducing waste, designing sustainable supply chains. Social good applications are expanding too.
So wrapping this up a bit, what are the really big takeaways, the key benefits of using OR? Why should we, care?
Well, the bottom line is significant improvements across the board. You get improved efficiency, higher productivity.
Okay, doing more with less.
Exactly. Big cost reductions and financial savings. We mentioned potential hospital savings. Avis Europe apparently saved around $19 million by optimizing their car rentals using OR.
Wow, real money.
Definitely. It leads to better, more informed decision-making backed by data, not just intuition. Better resource allocation, which we talked about. Often enhanced customer service because systems just run smoother. And reduced risk by understanding potential problems better.
So OR is this hidden engine driving a lot of optimization and efficiency in the world around us, often without us even realizing it.
That's a great way to put it. A powerful tool for making sense of complexity.
Which leads to a final thought, I guess. As we just keep generating more and more data about everything, how are these OR principles going to keep evolving? And, how will they continue shaping the really big decisions that affect our daily lives, our infrastructure, our future?
It's something to think about, isn't it? That hidden analytical power working behind so many things we use and rely on every day. Where does it go next?